pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Okay, we're going to be talking about the area of circles and the area of ellipses. If you want to write on your formula card, here is the area of a circle. The area of a circle equals pi r squared. We will be using pi equals 3.14. If you want to use your pi button, that is fine. So, but pi is 3.14, that's what I will be using, but it's okay if you want to use your pi button and then round. Your answers may be slightly different than mine if you're using your pi button, and that's okay. As a reminder, the units for area are square units. Square inches, square feet, square centimeters, square meters. Then we're also going to be doing area of an ellipse. Here's an ellipse. Ellipse does not have a radius like the circle. It has what's called a long axis or the major axis and a short axis or the minor axis. So long goes with major, short goes with minor, and the area of an ellipse is you take the distance of your major axis, the length of your major axis divided by 2, then take your minor axis divided by 2, multiply those two things together, then multiply by pi. It's very important to do your parentheses first. Order of operations says do parentheses first. So take the length of your major, divide by 2, the length of your minor, divide that by 2, multiply those two numbers together, then multiply by pi. Look at 13b11. We're dealing with a circle. Be careful here, we are given the diameter. Okay, we are given the diameter. So just know if you're given the diameter and you need the radius, you need to cut that diameter in half when you're dealing with the radius. The first thing we want to find is the circumference. Okay, formula for circumference, C equals 2 pi r, or you can use C equals pi times the diameter, whichever one you want. So I'm just going to use 2 pi r, 2 times 3.14 times the radius. If the diameter is 10, diameter goes all the way from one side of the circle to the other. If the diameter is 10, the radius is 5. And I'm dealing with inches, so I'm just going to do straight 3.14, not my pi button. So that would be 31.4, and circumference is just a length, it's just a distance, so that would just be inches, not square inches, square feet, or anything like that. It's not square units for circumference. Okay, now we're going to do the area of a circle. I always recommend writing your formula first. So area equals pi r squared. I need the radius. So pi is 3.14. My radius is 5, half of the diameter, 5, and I need to square that. Square your radius first, then multiply it by your 3.14. So 5 squared is 25. It's not 5 times 2. 5 squared is 25. So that would be 3.14 times 25. And that would be 78.5. And don't forget your units. I need to erase some of this to have room. That would be square inches. And remember, you can write it with your symbol. You can write square inches. You can write it like that as well. So 78.5 square inches. Okay, and remember, you might have a little bit slightly different number than me if you're using your pi button. Alright, let's look at 13b, number 14. And we're going to be doing the area of an ellipse. I always recommend writing out your formula. So the area of the ellipse is take your major axis divided by 2, then multiply it by your minor axis divided by 2, and then multiply that by pi. The length of your major axis. In the book it tells us that the long axis or the major axis is 10 feet. So 10 feet divided by 2. The length of your minor axis is 6 feet. Divide that by 2 and then multiply by pi. So 10 divided by 2 is 5. 6 divided by 2 is 3 times 3.14. So that would be 5 times 3 is 15 times 3.14. 47.1, and we're dealing with feet, so that would be square feet. 47.1 square feet. So that's just finding the area of a circle and ellipse. You'll also be working on the circumference. The other thing that the book talks about is latitude and longitude on a map. When you're dealing with latitude and longitude, you will see it written like this. This is red, 46 degrees, 52 minutes, 16 seconds. You do normally see these as feet and inches, but when you see these symbols with a degree, it is no longer feet and inches. It is now minutes and seconds. Again, 46 degrees, 52 minutes, and 16 seconds. This is used quite a bit in for airplanes, airplane navigation, and ships. So you need to know, you already should know, 60 seconds equals 1 minute. 60 seconds equals 1 minute. Everyone, you guys should know this at this point. The other thing to know is that 60 minutes equals 1 degree. So when this gets to be 59 seconds, when you get up to 60 seconds, you now can bump up to an extra minute here. When you get to where you are at 60 minutes here, that actually becomes 1 more degree. Okay? So here are some conversion factors to know. 60 seconds equals 1 minute. These symbols, seconds and minute. 60 minutes equals 1 degree. Okay, now I'm going to look at the globe. Show you on a globe. Let's just come over here to the U.S. You got that zoomed into the U.S.? I'll try to keep it still. I need the equator in here. Are we good? Okay, so these lines that go horizontal on a map are called latitude lines. You can remember that as they are flat. Flat latitude. Okay, they are called the latitude lines. Latitude lines are parallel with your equator. Latitude lines are north and south of the equator. These latitude lines are north of the equator. The ones down here are south of the equator. The equator is 0 degrees. Then as you go up, like this line, let's see, I think these are, oh yeah, every 15, each line is every 15 degrees. So here we're at the equator, 0 degrees. This solid black line is 15 degrees. Now go up again, add another 15, this will be 30 degrees. It will increase as you get up here to the North Pole. Then down below the equator, they still the same thing. This will be 15 degrees, then 30 degrees. How you know the difference is up here, you would call this 15 degrees north. 15 degrees in. That means 15 degrees, we are north of the equator, we are above the equator. Down here, this would be 15 degrees S, which means 15 degrees south of the equator. That's how you know the difference between the north and the south lines, since the numbers are the same. So remember, flatitude, latitude, flat, latitude. Okay, the other lines you're going to see, let me scooch over here. The other lines you're going to see on your globe are the ones that go up and down. The ones that go up and down from the North Pole to the South Pole are called longitude. I remember that just because long. I think of long from North Pole to South Pole, those are long. They're not necessarily longer, but I consider it that way. Long from North Pole to South Pole, these are called the longitude lines. The 0 degree line for longitude is the prime meridian, and that runs right here through Greenwich, in Greenwich Village, near London. So, or I don't know if that's considered in London, but it's near there. So, anyway, so that's 0 degrees. This is 0 degrees right here, called the prime meridian. It's like 0 degrees of the equator, but it's now the line running up and down, the longitude, 0 degrees. And then you have lines that go this way, and that are parallel to that. And again, they're going to be here, like this one right here is 30 degrees. But this one over here is also 30 degrees. So how do we know the difference? So here you're going to describe these as east and west of the prime meridian. Okay, longitudinal lines are east and west of the prime meridian. Okay, going this direction, these lines are to the east of the prime meridian. Over here, they're to the west. So that is longitude and latitude.